Ice, ice, baby. Ice, ice, baby.
In this heat of fusion of ice experiment, we will determine the amount of energy that is absorbed during the phase change of ice to water. We will obtain this result by calculating the mass of the water before and after the ice has melted.
The materials we used for today's experiment were a calorimeter cup, a bucket of ice, a 400 milliliter beaker with water, a paper towel, a digital thermometer, a mass balance with weights, and a hot plate.
For safety reasons, use caution when using the hot plate, for it can cause severe burns. To begin the experiment, we first filled the 400 milliliter beaker with water and placed it on the hot plate until it reached about 45 degrees Celsius or 318 Kelvin. We then measured the mass of the calorimeter with the cover and recorded our results in grams, in which we then converted into kilograms. After, we poured the warm water from the beaker into the calorimeter and once again recorded its mass. This was the initial measurement of the calorimeter plus the cover and the warm water before any ice was added. As we recorded the mass, we placed the digital thermometer in the bucket of ice to find its temperature. Next, we placed the digital thermometer in the warm water and stirred it for 1 minute until we had a stable starting temperature. It was crucial for us to maintain the cool temperature of the ice, so to avoid heat loss, the ice was dried with a paper towel and placed in the calorimeter without splashing any water. We then quickly covered the calorimeter and stirred with a thermometer until all of the ice had melted. If the temperature did not reach at least 12 degrees Celsius or 285 Kelvin, we added more ice and waited until it was fully melted to weigh it again. Our final step was to weigh the calorimeter plus its cover and the newly melted ice to determine the final mass. Before beginning a new trial, we made sure we fully dried the calorimeter so that there was no excess mass added to the beginning of the calorimeter weight.